This conference will now be recorded.
Some of you are aware of, you people are aware of this DevOps. See, okay, let me, because actually most of the people are non-DevOps, so I just wanted to give some small introduction about DevOps, and then we'll jump into the Azure DevOps. Now, coming to the DevOps is not a technology, first of all, right? So DevOps is nothing but it's a culture. So earlier, almost 4.5 5 years back, so be frank, actually there was no concept called DevOps. Okay, so but by the time actually we worked on independent individual tools like Git, like Jenkins, Ansible. So like this, actually we used to work on independent individual tools, and but after that, actually almost in the year 2016 something, so people actually they clubbed all the tools and they consider as a DevOps culture. So under this, actually we are having independent different tools like a Git, Jenkins, Maven, and Docker, Ansible, and any one of the what you called monitoring tools. Okay, so with the help of this, what we can do. See, I think you people are aware of this. Most of companies, almost 14 to or else 3 to 4 days, 3 to 4 years back, as in some of the companies still they are they're following the traditional deployment process. What exactly that? See, let's say for example, in traditional deployment process, once the developer once the developer commits their code, or once the developer completes their development activity, they are going to they will ask the they used to ask the release management people to prepare the CR, and they want to they used to involve all the members from different teams. Let's say for example, database team, development team, support team. So like this, actually they used to involve all the members in that particular CR window. And during the CR window, actually the people they are going to deploy the services, deploy the code from one environment to another environment manually. Okay, and after that, so what is the main drawback of the traditional deployment process? If you go with the traditional deployment process, the first thing is time consuming. So let's say for example, it's a time taking process. Let's say for example, today actually I have raised one CR. By the time, actually just assume that one of the team member is not available. Team member is nothing but let's say for example, database team member or the development member. Something is, he's not available, but as per the a CR task, okay, the release management team actually they started deployment at one particular point of time. They realized it that whatever the task they provided, they means the development team provided, okay, that is not sufficient, or I can say that that is not clear. So what will happen? So during that particular point of time, so either actually they used to they try to contact with that particular dev member. If he is available, then no issues. Otherwise, they used to reschedule that particular CR. Not only that, the second point, the second disadvantage, let's say for example, today I deployed my service from development to test environment, or test environment to stage environment. So once the code is transferred from one environment to another environment, make sure that there should be a proper testing. Okay, there should be some kind of a proper testing should be happen. Then only we can say that okay, our code is working in the next environment, that is in the test environment as well. So in general, if you go with the traditional CR process, whenever there is a code transfer, usually the what you call the UAT team members, sometimes actually they they missed that particular CR window. So they can say that, okay, once the deployment is completed, okay, they used to like ask the member to what do you call it, schedule another call to provide their test results. Okay, so that means today actually just assume that we scheduled one CR. Most probably tomorrow or day after tomorrow again UAT members will come and they will test the test. I mean, what you call the code, and after that they will submit the test results. Something is wrong, that means the future is not working. So they used to like trigger one defect saying that this particular feature is not working. So by that time again the development members they should work on that particular issue. Again they will push the code into the test environment with a new CR, and again actually the UAT member will come and test the data. Okay, so if you look into the entire process, every time actually we are spending more, I mean, in every case actually we are spending more time to get the results or to fix the defects. So to overcome that, what we are doing, and one more thing is that all the entire traditional CR process is manual, right? So make sure the member should deploy the code manually, okay, with the different tools. But now what happened coming to the DevOps, especially with the help of this DevOps, actually we are trying to automate the process. That means whenever there is a new code, we are going to pull the code automatically. That means with the help of these automation tools, we are pulling the code from the Git repository. We are preparing the build. We are preparing the like war or jar files. We are deploying the code into the next environment, and we are executing the test cases on the spot. If something is wrong, again we are sending a like what you call automation, automatic email notification. We are sending an automatic email notification to the appropriate team members, and based on that email they are working on that. Again actually they will pull the what you call, they are going to place the code in the Git repository. Again the process is repeating, and once it is done in the I mean, if everything is fine in the test environment, we are pushing the code into the next environment with the help of the configuration management tools. Everything is automated here in the DevOps area. Okay, so that is the reason actually here we are using one like a concept, or we are using one like a flow called CACD flow. CACD. Okay, CACD process. What exactly the CACD process? CACD process is nothing but continuous integration and continuous deliver. Sir, actually, so the CACD process is a 5-step process. One is the continuous download from Git repository, because developers actually they used to place the code in the Git repository. And after that, continuous CI, continuous integration with the help of the Jenkins mission. The Jenkins server, we are continuously we are integrating the code. And after that, continuous testing, CT, continuous testing. Okay, whenever the code is deployed in the next environment, we used to I mean, by the while executing the what you called build itself, actually we are executing the test cases. And after that, once the test cases are fine, then we are going to deploy the code into the next environment with the help of this configuration management tool, Ansible, Chef, or Puppet. With the help of this, we are automatically we are sending the code into the next environment. If everything is fine, again we are going to deliver the code into the production environment. So this is the actual CI/CD program. Okay, in between actually we are doing a number of things in real-time program. Let's say for example, if you go with the CD, I mean after the Git repository, after pulling the code from the Git repository, we need to prepare the build. So for that actually we are using the build tools like Maven or Ant, based on your technical what you call based on your technology which you are using while preparing the application. If you go with the Java, okay, people are using Maven as a builder tool. If you go with the .NET, people are using Ant as a builder tool. Okay, with the help of this builder tools, actually we are getting the XML files like the form.xml or the build.xml. So like this, actually we are getting the build files over here. And once it is there, we are configuring these two in the Jenkins pipeline. And with the help of this, we are preparing the var or jar files, and we are placing that particular var or jar file in the appropriate destination. Okay, and here, so like in real-time program, coming to the like a traditional DevOps, we are following these steps, CI/CD. Okay, so this is the traditional DevOps program. So here, Git is an independent tool, Maven is an independent tool, Ant is an independent tool, Jenkins is an independent tool, and the Selenium testing cases, testing tools are independent. Configuration management tools, Ansible, Chef, Puppet, all are independent. And then containerization tool called Docker. Okay, Kubernetes, all these are all independent tools here. And also in our traditional DevOps, actually we are continuously we are monitoring the applications. Okay, for this actually we are using Dynatrace, Splunk, Nagios, right? So like this actually we are using independent tools in our traditional DevOps. Why I'm saying traditional DevOps means, okay, so here we are, I mean, in next 5 minutes actually we'll talk about the Azure DevOps program. So by then there actually you will come to know like how we are using this particular tools altogether. So here, coming to this normal traditional like a DevOps program, we are using independent licensed versions for each and every, I mean licensed versions for each and every like what do you call technology. If you go with the Git, so in real-time program, we are using the licensed version. Coming to the Jenkins, we are preparing the like what do you call it? We are using the licensed Jenkins instance. Coming to the Maven licensed one, coming to the Ansible licensed one, Docker licensed one. So here we are investing, okay, uh, investing on n number of tools, okay, n number of tools individual, right? And also we are integrating all the tools with the help of this Jenkins. We are integrating all the tools. All the tools means Git. We are integrating the Git with Jenkins. We are integrating Maven with Jenkins. We are integrating Docker with Jenkins. We are integrating Ansible with Jenkins. We are integrating like Dynatrace, or we are integrating Nagios with Jenkins, right? So we are integrating all the tools with the help of this Jenkins as the Jenkins integration tool. So the point is here, in coming to the traditional DevOps, actually we are using independent, and after that, if you want to like prepare the build, so make sure that you need to integrate all the tools, okay, to prepare the end package, to prepare the end product. Okay, so here, so the point is, even whenever if you want to, like integrate, or if you want to launch a new application, new technology, so make sure that you need to integrate that particular technology in Jenkins. So for that actually you need to download the plugins which are available in Jenkins, Okay, so it is a like a I can say that the Jenkins will not identify, okay, Jenkins is not able to identify the default plugin which we need to use for the appropriate technology. So until unless if you are going to, if until unless you are until unless if you launch the plugin, if you download the plugin, then only it will accept that particular technology, that particular tool. Otherwise it will throw you the errors. Okay, so this is the traditional DevOps background. Okay, is this clear, all of you? Any questions? Any questions? Kiran, sorry, Anil. Can anyone, can you unmute and provide the answer? I mean, feedback.
I don't have.
No questions. Saujanya,
No.
No questions? Okay, Narayanan, no one, right? So till now actually we talked about traditional DevOps. So here, as I said, each and every tool you need to integrate with your Jenkins. Based on your requirement, you need to integrate the tool. One simple example, one real-time program. Let's say, for example, just assume for my application, I need to implement Sonar Cube. Sonar Cube is used for code quality purpose. Actually, we are using Sonar Cube, right? So there are like a code coverage gates will be there, and make sure that based on the instructions, based on the guidelines, our code should reach the minimum of 5 gates. Minimum of 5 gates. So for that, we need to integrate that, but we need to use that particular Sonar Cube in our application. So Sonar Cube is a separate tool, independent. Jenkins is a separate tool. And now, based on my requirement, based on my project requirement, I need to use that particular tool to verify the code quality of my application. So in this, actually, what I need to do? So I need to, first of all, I need to get the access for that particular tool, that is Sonar Cube. Once it is done, once I have that particular access, I need to integrate I need to integrate the Sonar Cube with Jenkins with the appropriate plugin. And after that, I need to write down the script in the Jenkins what do you call job. Okay. And after that, I need to execute. So here, the challenge is, let's say simple example. Challenge is, let's say for example, Sonar Cube is running, or Sonar Cube is compatible for, or else Jenkins is compatible for some kind of like versions, some part of versions. Okay, so by the time actually it's somewhat difficult to like download the plugin, Sonar Cube plugin, or 45, whatever it is, whatever the tool that you are using. So you need to, by the time actually there is a problem. If you want to, if there is a compulsory, let's say for example 45 scan or the Sonar Cube I need to implement, that is compulsory. Compulsory means like whenever I'm going to like download the Jenkins plugin, it is saying that some version compatibility issue, something like that. So by the time either I need to like upgrade my Jenkins version, or I need to downgrade or upgrade my Sonar Cube versions, right? It's like difficult for a single application. It is very difficult to upgrade my Jenkins server version, or for a single application. So I need to like it is somewhat difficult to upgrade my Sonar Cube version. Okay, it's a little bit difficult. Okay, so that kind of issues actually we are facing in the traditional DevOps area. Okay, but now coming to the Azure DevOps. So I'm repeating just one line. So here in the traditional DevOps area, we are using independent tools, and we are integrating all the tools with Jenkins to get the end product. But now coming to the Azure DevOps point of view, so Azure itself is providing the like their own pipeline scripts. Azure itself, okay, Microsoft team actually they introduced this Azure DevOps, which consists of the default Git repo, the default CI/CD pipeline, the default testing tools, I can say, and after that it will provide you the boards for your what do you call it, the rally related things. Okay, and after that it is providing you the the workspaces as well. Okay, all together. You no need to install independently. You no need to configure the tools you don't need to configure the independent integrate the independent tools here. So Azure DevOps is providing the package, total package, which will provide you the which will allow you to prepare your CI/CD program. For that, you can able to prepare the CI/CD. You can able to pull the code from the repository which the Azure is providing, and after that it will allow you to prepare the CI/CD program, prepare the job CI/CD program, and after that it will provide you to apply the test cases. Okay, it will allow you to prepare the boards, dashboards. Okay, and also it will provide you to place that particular code in one particular secure location, that is nothing but artifacts. Okay, that is the advantage of the Azure DevOps. Okay, here if you observe, so with the help of this Azure DevOps, okay, we can able to prepare the CI/CD program, okay, from one place. Okay, so you no need to, as I said, you no need to integrate the independent tools here. Okay, the Azure DevOps itself actually it is providing the package, the total package, and with the help of this actually you can able to prepare your CI/CD program. Okay, and also the main advantage of this, okay, here if you observe the Azure DevOps services, okay, it is providing the repos. I think you people are aware of this. We are having two different types of repos. Okay, one is a centralized repo and second one is the distributed repo. Okay, distributed repo. Okay, so the distributed repo we can call it as a Git here. Okay, so it is providing both the things, and also it is providing here, if you observe, it is providing the Azure repo, okay, Git repository, or the team foundation version control. The team foundation version control we can call it as a here centralized repository. And as you know, I think actually you people are using a distributed system only. Okay, in our real-time program, maximum cases, maximum companies, we are using the distributed repositories. That is nothing but a Git. Okay, and after that, the Azure DevOps is providing the pipelines, Azure pipelines. With the help of this, we can able to prepare the build, and we can able to provide the what do you call release services. Okay, to support the continuous integration as well as the continuous delivery. Okay, and also it is providing the Azure boards. I mean most of us actually we are working on the sprint based as well rally boards, right? For that actually we are using Kanban services. Okay, Kanban boards, something like that, right? So make sure, so the Azure dashboards, okay, with the help of these boards actually we can able to track our work, and we can able to provide the I mean we can able to list out the defects, and we can able to identify the what do you call defects, and we can able to work on that, and we can able to provide the what do you call the status of that particular defects. So all these things we can able to do it with the help of this Azure boards. And also, as I said, we can able to apply the test plans as well. Okay, so this is the integrated tools, and with the help of this we can able to test our code as well. And one more important thing is the test cases. I think you people are aware of this. We are not, as a DevOps engineer, we are not going to prepare the test cases or test plans. Okay, the application teams will provide you the test plans, and based on the test plans only we are going to execute. Okay, even the test cases will be provided by the a team only, the application team only. Okay, and also very important, the artifacts. Okay, and with the help of this we can able to save the, we can able to store the packages. Package is nothing but what do you call it, the pom.xmls or the build.xmls or war or jar files. We can able to store those kind of files in the artifacts area. Okay, and after that actually we can with the help of this we can able to generate the CI/CD pipelines in future. Okay, these are the main services provided by the Azure DevOps. Okay, and what are the advantages here? See, quick setup. Okay, there is no need to integrate the tools, right? And also maintenance also very easy, and collaborations across all the domains, and also the security. Simple thing, if you go with our cloud, there is a difference between the on-prem as well as cloud. If you go with on-prem, it's a cost effective, right? And second thing is maintenance as well as securities are very critical here. Okay, if you go with the on-prem, so maintenance point of view, as a DevOps engineer or as a cloud engineer, make sure, as a on-prem engineer, make sure that you need to make sure you should take the total maintenance activities as well as the securities also. You need to implement the n number of securities on your like a service to protect from the unauthorized hits. But whereas coming to the cloud technologies, see the service providers itself actually they are providing you the like a total securities. They are providing you the like a total maintenance. I mean the service providers itself actually they are taking care of this maintenance as well as securities. Okay, if you go with the security rules, security groups will be available, and after that we can able to implement the firewalls, we can able to implement the gateways. Okay, layer 7 gateways, something like that. So all these things will be available in our like cloud area. So just like that, so here we can able to maintain our the services, we can able to maintain, we can able to easily, we can set up the entire structure, and we can easily we can provide you the we can provide the like a solid security to our applications which we are preparing with the help of this Azure DevOps. Okay, any questions till now? Any questions, Anil, Saujanya, uh, Narayanan?
No, please continue.
Okay, and also here we are having two different types of DevOps programs. One is the Azure DevOps Services and Azure DevOps Server. So Azure DevOps Service is a cloud offering one. Okay, so here you will get 99.9% SLAs, like what you call the tracking, and also 24/7 monitoring will be available here. Okay, coming to the like the Azure DevOps server, it's an on-prem. Okay, so just like our normal DevOps program, normal on-prem services. Okay, so like this, actually, we are having like two different. And one more important thing is, with the help of this Azure DevOps services, we can able to launch, or we can able to use our services in all the like what you call the available data centers. As you know, coming to the cloud offering, actually, we are having like a number of data centers will be provided by the like is providing by the Azure. Okay, Microsoft team, almost 54 countries and 140, sorry, 54 regions and 140 countries. Okay, these services are available, Azure services are available. Okay, you can able to launch based on your business requirement, you can able to launch your service in any one of the region as well as any one of the availability zone. Okay, this is the like main advantage of this Azure like a public cloud, I mean services. Okay, so this is about just I have provided some kind of introduction about the repository. Okay, so like here also actually we are using the distributed repository mainly. Okay, compared to like what you call the centralized repositories. Okay, that is fine, right? Compared to the centralized, okay, maximum we people are using the like a distributed. Okay, by with the help of this we can able to like maintain the local repository, and after that once the code is up and running, once the code is fine, then we are going to like push that particular code into the main repository. But whereas coming to the centralized systems, so once you prepare your code, so there is no other option, you make sure that you should send that particular like a code directly into the centralized central repository only. Okay, that is some kind of like a issue, right? So if something is wrong, again actually you need to like revert back the changes, or again you need to prepare the you need to verify the code, and you need to fix the defects, and again you need to send it back to the like a central repository. But whereas coming to our distributed, there are multiple plans, there are multiple stages are available. So if I mean once you complete your code in your local machine, you can move to that particular what do you call code into the tracked area, that is nothing but a staging area. There you can able to test it whether that like code is working fine or not. If not, actually again you can there is an option, you can come back to the, you can move that particular code back to our untracked area. Again you can fix that particular issues, or you can test it again, you can push that particular code into the next, what you call next stage. There is an option that is distributed. There is the flexibility, but whereas coming to the centralized, this kind of flexibilities are not available. Okay, so this is about the repos, and here we are having the pipelines. Okay, these are the main advantage of this Azure pipelines. Okay, so we can able to prepare the a CI/CD pipeline, or that is Azure pipeline with any language or any platform, and we can deploy it to the different types of targets at the same time, and integrate with the the Azure deployments and build on the Windows, Linux, or the Mac machines, and we can able to integrate. So this is compulsory, right, to get the code. So we can able to integrate with our GitHub and works with the open source projects as well. Okay, so these are the advantages of Azure pipelines. And also test cases we already discussed. Quality point of view, make sure that you need to test your code before moving to the next, before releasing that particular code into the next environment. Make sure that you should complete your test them. And one more important, as I said, as a DevOps engineer, if the test cases are available, test cases are provided by the development team, then only we can able to execute. Okay, otherwise actually there is no other what do you call the chance or the other option. Okay, until unless if the test cases is available, then only we can able to test it. I mean, then only we can able to execute the job. Otherwise, actually, a normal job will run, and the code will be deployed to the next environment. Whether if there is a code issue or not, we least bother about. But as a standard, as per the standard process, make sure that testing should be happen on the code level. So for the testing should be automate. Okay, for that we are going to execute the test scripts. Okay, along with the code with the help of this CI/CD pipelines. Okay, and the last one is artifacts, as is discussed. So once you prepare the code or once you build the package, you will get the war or jar files. In general, there is a difference between the workspace as well as artifacts. In our normal Jenkins, also we are having the workspace. The workspace will allow you to save your job for short time. Let's say, for example, just assume today actually I have executed one job at 8:42. Okay, that particular file will come and save, will be available in the workspace area. Okay, so that let's say for example version 1, I can say version 1 is available at 8:42. Let's say for example on the same job, okay, I just wanted to re-execute the same job at 8:45. So by the time what will happen? Okay, the code will, the CI/CD program will execute. Okay, and you will get a new file. This new file will be go and overwrite the existing one. So that means 8:42 file will be gone from there, and you will get the 8:45 job, 8:45 file. Okay, that is the main drawback of this workspace. But whereas coming to the artifacts, you can able to save your files, and you can able to save your packages. Okay, whatever the packages that you are that you are preparing, you can able to save it, and you can able to reuse that whenever you need that particular existing jobs, existing packages. Okay, that is the advantage of these artifacts. Okay, let's say in real time, in general, in our a traditional DevOps. Okay, again, artifacts is like a third party. You need to integrate that particular artifacts with your Jenkins job. Okay, any questions? Any questions regarding this session? Azure DevOps or the traditional DevOps?
Can
Anyone?
you
Can you?
please explore more about testing related one?
Testing related. See, in general, coming to the DevOps point of view,
Hmm.
what will happen? See, we are using the test plans, right? We are having the default test plans, but those default test plans will not, I mean, those are not sufficient for our regular applications. So for that, the application team, what they will ask you, they will ask you to prepare the what you call they will ask you to execute the test cases which are provided by the application team. So that means what it means. Simple example. Okay, for your understanding, I said one tool called 45 scan. Sorry, 45. Sorry, Sonar Cube. Sonar Cube is having like a multiple gates: gate 0, gate 1, gate 2, gate 3, gate 4, gate 5. In general, the code quality purpose. Let's say, just assume that while preparing the code, application team actually they miss the test cases. Try to understand. They miss the test cases.
Okay.
So by the time actually what will happen? See, there is no harm to your DevOps CI/CD program. CI/CD program will run. It will prepare the package. It will prepare the what you call war file, and it will store that particular war file in the artifacts area, JFrog or whatever it is. So here we are not testing the code, right? Because there is no test case. We are not testing the code. So whenever you are going to deploy the code into the production environment, let's say for example, without testing, see in general, make sure that the testing should be happen in the lower environments as well as the, I mean, before launching the product into the production, make sure that your testing, I mean, product should be tested thoroughly with your test cases. As I mentioned in the scenario one, there is no test case. What will happen? So our CI/CD program will not touch that particular test like a test case area. Other than that, it will execute the entire package. It will prepare the war or jar file. It will send it to the next environment. That's it. Our job is done. But coming to the application point of view, application business point of view, they are asking us to please integrate the testing, what you call testing tools as well, test program as well. So by the time what I'm doing here, I am preparing the Sonar Cube, I am preparing the quality gates. Okay, and after that I integrated the Sonar Cube with our CI/CD program, that is a Jenkins. Okay, this is my job. And after that, I need, so the development team needs to prepare the test cases, unit test cases, and they need to place it in their like a pom.xml or the build.xml in their packages. They need to place. That is not our job. They need to place, application team. Once the test case is ready, okay, whenever I am going to execute the CI/CD program, Jenkins program or the pipeline, what will happen? So build will be coming. Okay, build will be available. After that, one second. After that, it will execute the test case. Okay, let's say for example, test case is failing. Something is wrong. Test case is failing. What will happen? So it will give you the failure message. So that means the code will not be available or code will not be transferred to the next environment. Whether it is a test or production or else a stage environment. Okay, so it will clearly in the console area, it will show you the error message. It will show you the error message. Okay, so as a DevOps member, as I said, we are not the responsible person to verify the test case. We are not the responsible person to recreate the test cases. Okay, based on their unit test case, their code is not working as per their test cases. Okay, that is not our job, right? So make sure whenever there is a failure, okay, as I said, an email notification will send it to the appropriate team, and based on that email notification, the team will, the development team or the testing team will work on that. Again, they will place the latest code in the Git repository. and again our CI/CD pipeline will re-execute. Is this clear, Sajini?
Yeah, but
Hmm.
since 2 months, we are also using Azure Devops while creating test cases,
Hmm.
executing everything we had done with only Azure Devops only. Earlier, we
Okay,
are using MTM tool, Microsoft Test Manager tool.
correct.
So, means you told like application team only they'll prepare test cases.
Hmm.
They should,
Hmm.
but uh, we testing people only. We prepare test cases. We are executing. We are
One
raising
second.
bugs.
One second. Here,
Uh,
application team means actually, see, they are preparing the test cases means application side actually they are having their own testing team, right? See, from DevOps
mm,
point of view, our team is different. Application point of view, development, testing, and their some team all together. We can call it them as a application team, right? Okay, see, developers actually they are not going to prepare the test case, right? They will prepare some kind of unit test cases only. And after that, actually, the coming to the UAT program, so the testing team, okay, they will prepare the like a thorough test cases and they will test it. See, simple program, simple example. So let's say, for example, I am a developer and you are the testing member. As a developer, what kind of test cases that I am going to write down? Simple. As per my, see, whatever the code actually I have prepared, so based on my code, actually I'm going to prepare the test case, right? 100% my test cases will be executed. Am I correct?
mm,
Right?
yes.
See, there is a
Mm,
difference, right? So because actually I have prepared my own code, based on my code, actually I'm going to prepare the unit test cases. By the time the 100% my unit test cases will be success, will be passed. But where we will get the like a real what do you call it test results. The testing team member actually they will prepare the test cases based on their what do you call it business team requirement. They will prepare the test cases and they will provide it to the development team, and based on that test cases, I mean once they receive the test cases they will place it in the code level, right? You got my point, Saujanya?
yes, yes, got it.
Right? See, here
Mm,
application team is nothing but, see, I am a DevOps member, I'm the architect. So from my point of view, my own team is nothing but DevOps. Application point of view, in my mind, actually, application team is nothing but a development team and their respective like supporting teams like testing, Scrum team, etc. You got it?
yes, got it. Please continue.
Okay, so this is about any other questions? No?
Yeah, hi Ram.
And
I have one question.
yeah, please.
Like I'm not sure, but I think most of us is not having any Azure kind of experience. So how this Azure DevOps will help us in coming days?
Sure. Okay, good question. Mm, good question. See, program is ultimately nowadays all the application, all the companies, they are trying to like migrate their application from on-prem to cloud. Okay, on-prem to cloud. So wherever there is a like Azure DevOps is implementing, or else Azure infrastructure, Azure cloud is implementing. So most of the companies actually they will go with this Azure DevOps. Azure and Azure DevOps, there are two different. Azure is an infrastructure preparation, okay, in the cloud. Okay, Azure DevOps is a again the Azure DevOps services which we are preparing the CI/CD pipeline in the cloud level. Okay, so there is a dependency. I can say that actually those who are using the on-prem services, they are not going to use this kind of like Azure DevOps related. Those who are using the cloud technology like Azure or AWS, those people actually, those companies actually, they are migrating to the Azure DevOps, migrating to Azure DevOps. See, simple thing is, see, in my company actually we are using Azure, AWS, and everything. Even actually we are maintaining the like what you called on-prem services, on-prem applications as well. So for on-prem, actually, going forward, actually, we are using the traditional DevOps. But whereas coming to the application which is available in the cloud, for those applications, actually, we are preparing the Azure DevOps. We are using the Azure DevOps. Clear, Deepak?
Yeah, that's fine. But since we don't have any experience in Azure, so would you recommend that we go directly to Azure DevOps instead to go directly to Azure?
Okay, good. Yeah, good question. See, having two technologies always suggestible. Okay, learning two technologies always suggestible. And one more thing is these two are two different. One is for infrastructure preparation, and second one is for deployment purpose. Azure DevOps is a deployment purpose, right? Azure is an infrastructure, and they can say that there is no interdependency. Okay, straightforward. There is no interdependency, but there is a communication between these two, because once you prepare the infrastructure in Azure, okay, with the help of Azure, and what is our next job? We need to deploy our service to the cloud, to the Azure cloud, right? So by the time you need to establish a communication between the Azure as well as Azure DevOps program. Okay, that is infrastructure in the cloud as well as the deployment process which you are following. You need to establish a communication between these two. Then you need to concentrate how to communicate these two, how to establish a communication between these two programs. You need to what do you call, you should be aware of that. But suggestion is having Azure and Azure DevOps always, it's a plus point. See, because actually going forward, people actually they are using Azure DevOps what do you call it regularly. At the same time, all the applications are migrating to cloud. So after some time, already 90% of our companies actually they already started migrating to the cloud. Okay, once the application is available in the cloud, the next step actually they are going to prepare these CI/CD programs with the help of the Azure DevOps. Okay, so always having two technologies always is a plus point. Okay, suggestion is go with the two, or else you can go with Azure DevOps. Once you learn this again, you need to get some kind of idea and how to set up the infrastructure in Azure. Okay, with the help of Azure. Okay, make sure you should have that. Deepak.
Thank you, Ram.
Okay, any other questions? And one more thing, so if you don't have any questions, the one is the total program is 30 to 35 sessions, 30 to 35 hours. And second thing is total practical sessions. There is no theoretical. Okay, 5% only theoretical sessions, and rest of 95% all are practical sessions only. Okay, this is about. And if you have any questions, please let me know, or else please provide your feedback to Kiran, and based on your feedback, and we'll start the sessions.
So Ram, once you are doing the practical session in front, so how we can catch up? Do we need to do the same thing at the same time, or how?
No, actually, see, anyhow, recorded session will be available, right? First of all, observe how I am preparing the CI/CD program with the help of this Azure DevOps, and how I am preparing the things in the DevOps in the Azure level. Okay, so anyhow, actually, you will get the recording, and based on that, actually, you need to practice in your free time. In some cases, I'm going to provide the scenarios during the session. So by the time, actually, you need to do it parallelly. You need to do it parallel.
So do we have? Yeah, go ahead, please.
So I can say that most of the sessions actually you no need to, we are not going to practice the sessions parallelly while running the session. No need to practice parallelly. I'm saying during the class, but make sure that everyday practice is must and should. Okay, but some cases whenever if I want to like provide any kind of scenarios, so scenarios will be provided even to all the members. Okay, in all the batches. So during the time, actually make sure that you should complete the scenarios, and you need to like you should practice the scenarios parallelly. Okay, along with me. And during the time, actually, whenever if you are facing any kind of issues, okay, I will guide you how to overcome that particular issue and how to write down the pipelines and everything. Clear, Deepak?
Yep.
Any other questions?
So like if we need any kind of troubleshooting or any assistance, so who will take care?
Myself, I will guide you. Don't worry about it.
So what would be the timing, like in evening IST or morning IST?
Actually, morning time. Actually, we are planning to start the session at the same time, 8 to 9. Evening also, we are planning to start the sessions 9 to 10, 9 p.m. All are in ISTs only.
Okay.
Okay, two batches actually we are planning. One is in the morning, 8 to 9 p.m., 9 a.m. IST, and based on the what you call the requests or something, and we may change the timings as well from the majority. I mean, based on the majority of requests. And in the evening, actually, we are planning to prepare. I mean, schedule the session from 9 o'clock or 8:30 to 9:30 something.
So Ram, where we can see the course content which going for
Course content will be provided by Kiran. Kiran will share with you shortly.
Okay.
Okay. Yeah. Kiran mentioned the timings, Deepak. 8 a.m. to 9 a.m. IST one batch, 9 p.m. to 10 p.m. IST another batch.
All right. Thank you.
Okay. Yeah. Thank you all. Have a nice day. Okay. Please provide your feedback to Kiran, and based on the feedback, we'll start the sessions. Thank you all. Have a nice day. Thank you.
Thank you.